Okay, this is a video for 2.3, which is composition of functions. Okay, that's today, October 9th. That's what we're doing today in class. So yesterday we talked about the algebra of functions, where we added them or subtracted them or multiplied or divided them. So today we're going to talk about the composition. And composition has this lovely small circle. And what that really means is this is the same thing as g of f of negative 2. Sometimes I write it that way because it helps me. So I have to start on the inside of the parentheses. So I'm going to find f of negative 2 first. And I might go off to the side and find what is f of negative 2. Well, f of negative 2, remember f is 3x plus 1. So this is 3 times negative 2 plus 1. So I do this first, negative 6 plus 1, negative 5. Once I have that answer, now I'm going to say, okay, what is g of negative 5? Okay, so start on the inside parentheses and you work your way out. So g of negative 5 is, g says negative 5 squared minus 2 times negative 5 minus 6. So 25 plus 10 minus 6, I think that's 29 this morning. I don't know. So this is 29. Okay? So that's how I do these. I'm going to skip the one in the middle because I don't have enough room. So now this one is f of g of 1/3. Now you have to make sure you do them in the right order. And again, I like to rewrite it as this because that works better for my brain. You can do whatever. I don't know what you learned last year. So off to the side, g of 1/3 was 1/3 squared. I'm going to have to break out my calculator. Minus 2 times 1/3 minus 6. So then I have to find a value for that. Let's see. I'm breaking out my calculator here as I wasn't prepared. So parentheses 1 divided by 3, close the parentheses squared, minus 2 times parentheses 1 divided by 3, close the parentheses, minus 6. Oh, negative 6.555. So if I make that into a fraction, because it's a repeating decimal, my calculator says negative 59 over 9. You should really keep all of it. Don't round it there because we still have to do f on those. So I'm going to now do f of negative 59 over 9. I have a calculator, so I don't really care. So f says 3 times that plus 1. So f of negative 59 over 9 says 3 times that plus 1. So I'm going to multiply that times 3 and add 1 on my calculator. And again, it's a repeating decimal, so do fractions, and my calculator gives me an answer of negative 56 over 3. Okay? So that's what you're going to want to do there. Start on the inside. Now those are not so bad because those are numbers, but you know it always gets harder when we have just letters. But we're still going to do the same thing, okay? F of g and then g of f. Unfortunately, you should not expect the same answer when we do these, although sometimes we get the same answer. But just so you know, you should never expect the same answer. So I'm going to do f of g, or fog, as sometimes kids like to say, but I'm going to write that as f of g of x. So now I'm going to put g of x in this spot right here. So right here, game of substitutions, I'm going to put this right here. So this is 5/4 x. So now I'm doing f of 5/4 x. So f says to take 4/5 times whatever's in parentheses. And this is 5/4 x. So when I do that, I get at x. Right, the 4 and the 5 cancel. Okay, so g of f of x. What this says, just FYI, is if this next one works the same and gives me x, that means f and g are inverses of each other, which you might have suspected when you had reciprocals in front, but they're inverses of each other. So let's see if this gives us f, then we have an inverse. If it doesn't give us x, then we don't have an inverse. Okay, so now I'm doing g of f of x. So now I have g of f is 4/5 x. And now g says to take 5/4 times whatever's in parentheses, which is 4/5 x, and notice I get x back. Okay? Now, I have to find the domain of each. Well, remember yesterday we talked about domain, and are there any fractions or radicals? And you say, well, there's this fraction 5/4 or 4/5, but that doesn't really count because the x is not in the denominator. We only care if x is in the denominator or if it's in a radical. And if x is not in the denominator, then my domain for both of these is all reals. Remember how we wrote that yesterday? The domain, I'll put it out here. Remember, the domain is all reals, so we say negative infinity to infinity. So those are inverses of each other. That doesn't happen very often, just FYI. Okay, so here we go. Now this is definitely not going to be the inverse of each other, and we have to be careful with our domain because we have some fractions. So I want to do f of g of x. So I'll start with that one. F of g of x. If you want to just go ahead and straight write it, f of g of x, that's okay. So now I have to do f of g. G is 1 over 2x plus 1. Okay, and so right away I notice in this, x can't be negative a half. If I'm going to solve the denominator for 0, x can't be a negative a half, so I have to keep that in mind. Now I have to do f of this, and f says 6 over whatever's in parentheses, so that's 1 over 2x plus 1. So I say, oh, that's a mess. But I'm like, oh, I'm just dividing by a fraction. So that's the ever popular keep, change, flip, right? So it's 6 over 1 times, flip the bottom, 2x plus 1 over 1. So that becomes 6. Remember, fraction bars act like parentheses, so that's 12x plus 6. And you might be tempted to say that that's all reals also, but it's not, because remember, back up here, we had an x in the denominator, so we can't have an x in the denominator anywhere. So here, I'm going to end up with, remember 2x, well, let me change colors, because I can, so it's easier to see instead of all this other stuff. Maybe it's not easier to see, I don't know. So when I'm working on domain, I have to look, and I know that 2x plus 1 can't be 0. So I subtract 1, and I get 2x can't be negative 1. Divide by 2, x can't be negative a half. Okay? So I look through, and I don't see anything else in my denominator. So I say negative infinity to negative 1/2, union negative 1/2, comma, that's a comma, doesn't look like a comma, but it's a comma, comma, infinity. Okay, so now let's do the other way. Let's do g of f of x. I'm going to run out of room, better write small. Okay, so now I'm doing g of f of x. So that's g of f of x. F of x is 6 over x. So this is g of 6 over x. Now I can't have 0 as a denominator, can I? Okay, so now let's do g. G says 1 over 2 times whatever's in parentheses plus 1. So that means I've got 1 over, it's easiest if I have common denominators in the denominator, so I'm going to multiply that by x. So I'm going to have 12 plus x all over x. And notice I still can't have 0 in my denominator. So I keep change flip, so 1 times x over 12 plus x. Now look what happens. I can't have negative 12 now, can I? So x can't be 0 and x can't be negative 12 because those both make a denominator of 0. So that means my domain is going to be from negative infinity to negative 12, union negative 12 to 0, union 0 to infinity. Bam. All right, I don't have enough time to do this next one because I don't want to take, 20 minutes. So keep that in mind. F of g of x and g of f of x is a game of substitutions. Okay, substitute in. All right, good luck. Let me know if